Tell me about your upper body tracker.
Okay, so what I did for this project is I used a skin detection algorithm, which is very simple. It's linear. It's not a log-based. It does not use a log-based color scale, and it simply removes the intensity. And you can actually detect different skin colors with it with the same algorithm. So what I do is I take the video feed, determine whether or not a pixel could be a potential skin cell, skin pixel, and take the spatial average and the temporal average of the pixels. And you can see here we have a downsample. So here is a real-time video feed coming from this camera. And here is a downsampled version, average version of all the pixels that qualify as skin pixels. As you can see, it's tracking my head and my hands pretty clean.
And when you say different color skin, so it works on people with browner and pinker skin, and it seems to work with pretty much everybody you've tried?
Yes.
Nice.
So I've tried it with, and what I did was, if you can see, I divided the screen into 3 sections. You've got the top section, which is the top, and the red dots are the centroids. The bottom 2 red dots track the arms, so they're the lower left and lower right corners. And what I did was I take these centroids and I plotted them, and I made a little projection with it so that I can sort of model a 3D human, coarse model of a human.
Okay, so I'm going to back up now so I can see you.
So I can flap my wings, move around with my head, and you can see the projection of the head tilts. That's computed based on the centroid of the head, and the body just follows the head. And I could do things like, and they're all updated simultaneously, so you could do things like sweeping around. So the updates are simultaneous.
Now, I may be in the image.
Yeah, you may be in the image.
So I need to get back out of the image a little bit.
So what it does not do is, if you were to do a cross arm, if you were to cross your arm, then I can't tell apart the arms because I did the recognition through partitioning. But of course, it would be, it could be like a future extension of the project if somebody were to, continue. So yeah, that's what it looks like.
So, wow. Yeah. So turn it back to the red dot mode there.
Yeah. And I can show you how it tracks. So those are the dots and the head.
It's quite robust.
Yep. Everything's completely combinational, very fast, and the entire system only uses about like 27% of all the onboard elements.
And this is on a DE2?
It's on a DE2, yeah.
And the you say it's combinatorial in the sense that on every pixel, at every pixel time then, or on every frame time, it decides
Yes.
a new centroid.
Yes. In addition to that, the algorithm used to do the skin detection is also completely combinational, so you don't have to do a lookup table.
So there's no registers? There's no registering at all? It's just, it's literally...
It's not, well, by registering, I do store the downsampled skin pixel in an M4K block. But other than that, there's no registering.
Okay.
Yeah.
Very cool. Thank you.
Yeah, no problem.